Oh, it's streaming. Beautiful. Oh, it just works. I'm so happy. I have a machine that operates, that functional. Fantastic. Okay. Good morning, everybody. I think this quote probably encompasses this year the best. This is our strategy. Improvise, adapt, and overcome. We're going to be doing that a lot. Hey, because I don't have to run Zoom, we should be able to get the camera working here. Maybe. Maybe not. All right, something to mess with. No camera on YouTube stream because Zoom is a hog and it is selfish and it doesn't like to share. So working on a way around that. But at least we have this. This works. It's part of overcoming. All right. This. Oh, look at that. There's our textbook. It's right here. All this good stuff. Okay, awesome. So today I want to get into our topic of quadratics. Okay? And first thing we're going to do is multiply those expressions. With those. So roll the clock back a little bit. Let's go vocabulary. What is an omial? Okay. A monomial is one term. You remember adding like terms together. They can have different numbers, but they have to have all the same letters, and that makes it a monomial. And then when you put two of them together, if you have two unlike terms that can't combine, that pair would be binomial, and then two of them would be a trinomial, right? And then we get all the polynomials. In fact, our textbook starts us off with polynomials in general. Now, because we're following the Khan Academy structure more closely than this setup, we're going to be bouncing around between a couple chapters here as we get started, and they'll merge together a little bit. But we want to focus just on the quadratic polynomials, right? So not quite the simplest. The simplest one would be monomial, but they're so simple they don't do anything interesting. They just stand there by themselves. It's not that fun. And you can multiply a monomial by another monomial, and that's just multiplying numbers. Right? And if you multiply the variables, you just increase the powers. Right? B times a b squared, and now you've got b cubed. Right? It's just exponentials. So where it really starts to get interesting, we scroll through all of these. Once we get to polynomials that have like and unlike terms, we can get to the binomials. And we can multiply them by stuff. And now this is where the multiplication gets fancy. Because it's not just one thing. Because the binomial represents two things at once, but is really one thing. Okay? That's where you're going to have to start thinking in your head. When you see stuff in parentheses, start treating it like one thing sometimes, and other times you'll dig into it and treat it like multiple things. Okay? It's a box with stuff inside it. So this says we want to multiply the whole box by this number, which means everything in the box gets multiplied by that value at 2x. And we're then going to use the distributed property that says, okay, this thing goes here, you get 2x times 7x squared, this goes here, 2x times negative 3x. This one's one step advanced. Right? This is a trinomial. Well, we got to do binomials. If you like, you can think of this visually. This is one of the reasons I wanted to bring up the textbook here. I don't know if you guys used algebra tiles before, have you? You have? Okay, so you've done this, right? This visual representation of the numbers, just like geometric areas. You take the length of one side times the length of another. Well, what if those sides weren't just 5 and 7? They were x plus 5 and x plus 2. You don't know what x is. But you can represent it as some size that is not the same as 2. And then you can look where those grids line up. Say, this is going to be an x times an x. I've gotten used to checking the camera now, and now I don't have to. So, but now you can see where those line up and create that x squared tile. And so your result is just to add together all of the same shaped tiles. So for the visually inclined, this is really useful. And notice here, because of that representation, the order doesn't matter. Right? Whether you think of it as, I'm going to distribute the x plus 5 into the x plus 2, or distribute the x plus 2 into the x plus 5, it's still multiplication, it's still commutative. Right? So long as each thing in one box gets paired up with each thing in the other box. Right? And that's why we have all of those tricks about drawing your lines, right? And then you go underneath, and that's to help you keep track of what has been used before. But the best full visual would be to lay them out as a grid with the algebra tile-like setup. In fact, they sometimes call this the box method of multiplying, where you will write them out as, okay, I have my x plus 5, and here x plus 2, and you'll create a grid here. Right? So you make sure everything gets paired up. And if that helps you keep track of information, fantastic. Especially when we do get to bigger polynomials in like a month. Okay? You want to make sure you don't miss anything. All right. FOIL. If you like mnemonics, FOIL can be grand. However, FOIL is limited, because FOIL only applies to binomial times binomial. And so if your only thought of how to deal with this problem is, I must FOIL it, and then all of a sudden we go binomial times trinomial, you're like, oh shoot, which one of these is inside, which one is now last? But it's going to confuse you. So forget FOIL. Honestly, don't use it. I don't think it's any more helpful, except maybe in 3rd grade, than just distributing. And you're better off with the box. All right, and then they have laying average, what they call first, outer. I don't care. It's just another way of keeping track of things, but this is more limited. All right. Let's go ahead. Let's do one together. Just so we're all on board here. And then I'll turn you over to the worksheet. And then you can run through those practices on your own. Okay? So I'm going to go with 13 to start with. Right here from the book. So we're looking at 2z minus 1 times a 2z plus 1. See some repetition there. Oh, 2z and then 2z again. So you want to be extra careful. Maybe you see something duplicated again. It becomes extra important to make sure you have a system in place of keeping track of what's been used so far. Which 2z is which 2z. And don't confuse the two. Which one is which one? Notice this is where it really becomes important to start thinking, this is not minus 1. This is not 2z minus 1. How should your brain interpret that? What would be a better way than saying 2z minus 1? Negative 1. Right? I want you to start grabbing that minus sign, and let's see if I can do this. I'm going to color it out, and I'm going to scoot it over. I want you to imagine moving all of your minus signs closer to the numbers. Okay? So that this is actually 2z plus negative 1. I know it feels less efficient to start doing that. You got so used to, hey, oh, we can just drop this and it's plus and negative. Oh, that's just minus. Minus is no good to us anymore. We're in Algebra 2 now. Okay? For the rest of your math career, you are never going to subtract again. You're just going to add negatives. It will honestly lead to fewer mistakes if you think in those terms. So doesn't mean it'll eliminate it completely. So with that in mind then, let's take our first number, distribute that, 2z times 2z. Numbers multiply together, 2 times 2 is 4. Z times z is z squared. Okay. I put the bar across my z so that you can tell I didn't write it too. Okay. Next up, 2z times 1. So that's just a positive 2z. And now we've taken this, we've done to all of the things over there. And I'll move on to the next item in the first box. I have the power of switching colors, so I'm going to make use of that here. Take the negative 1 times the 2z, we get negative 2z. Yes, I'm going to write that down for clarification. And then finally, negative 1 times positive 1 would just be negative 1. Right? I would never write all of this down myself. Okay? Hopefully, you can see, hey, those terms are going to combine. Those are going to give you the same letter. As soon as you know that you're going to have the same letters, right? Wait, this letter times not letter, and not letter times letter. Right? Matching variables. As soon as you notice that, you should know those terms are going to combine. Right? You're trying to think ahead. Do as much mental math as you can. The paper is to help you keep track of it. We're also trying to save time. Let's hot mental math trick. Combine those in your head. You can keep track of 2 numbers in your head. You wrote this one down. You don't have to think about it again. Okay? Drop that from your working memory. Don't need it. Just go 2 times 1. Okay, that's a positive 2. Hold that positive 2 in your mind while you do the next one. And you get a negative 2. Combine those numbers, just write down that final result. Right? It's going to save you loads of time. Now in our case, we actually end up with a rather unique result here. Because what is positive 2 plus negative 2? 0. Do we need to write down a term with coefficient of 0? No, we don't even have to write that at all. It is just 4z squared minus 1. Right? Isn't that special? It's actually literally special. That is the correct mathematical term. We would call this a special product. We'll talk more about those later in the week. Right? But this is the kind of thing you're starting to look for. Like, ooh, something unique happened here. I wonder why it did that. What can I identify about the initial question that led to this special uniqueness of an answer? The fact that the center term totally deleted itself. Why did it do that? Because if you can identify why it does that every time, you can spot it ahead of time, and then, again, say to yourself, mental math, now I don't even have to add these 2 numbers together in my head anymore. I know they're going to go away. Right? And this is the difference between memorizing and understanding. Right? If you just memorize the FOIL method, I'm just following the process every time. I know the steps in order. That's a good start. But if you can understand why they work, and just practice it enough that your brain does it automatically, it's just as good as memorizing. It's just as fast. But it comes from the practice and the recognition. Right? Real world experience leads you to do it faster than just forcing a memorization. Does that make sense? Okay. So, because of all of the rest of the world's stuff landing on our shoulders this year, content-wise, I feel like we're moving kind of slow. You might feel like we're moving kind of slow. Like, yeah, we did this like for a week last year. Why are we spending a whole day on this one thing? Totally agree with you. We could rocket through Algebra 2, especially because it is online. It's like, that allows us to go faster if there was nothing else getting in our way. But the reality is there are things getting in other people's way. So just because you feel, it seems so simple, why am I wasting my time with this? Please be considerate of others. Okay? And then take this opportunity to say, all right, I know how to do this. But do I know how to do it faster? Can I do it better? Okay? More practice is always good. Right? Like, in what other realm of your life do you ever decide, no, I don't need to become any better at that. It's fine. Like, aren't you constantly looking for ways to do it better? If you could, like, cut the time it takes you to do laundry down 30%, wouldn't you do it? Finish laundry faster? If you could find a way to get your eggs in the morning to somehow cook faster, but without, like, getting crispy around the edges, you don't want to burn them, but you, like, want to have them cooked faster, but still taste the same, you do it, right? And the reason we don't microwave them is, yeah, it's faster, but they just don't taste it. And so there's always these trade-offs. How can I find a better way to do this? We're practicing to find better ways to do this. Right? I'm going way more in depth on this one thing than I ever thought. At the, earlier in the day, wait, there's a lot more things to consider here. A lot of little tricks mentally that can make this go smoother. Help you do it faster, more efficiently, which is cool for its own sake, but also pay dividends later down the line when we do more complex things. This won't hold you back. Right? SAT, that test is still going to happen eventually. You want to do as good as you possibly can, right? So you want to turn as many possible SAT questions into easy questions as possible, right? And by mastering these techniques through seemingly an excessive amount of minuscule practice, you'll get there. I hope I've convinced you. I'm going to try to keep it not boring, but some days there just might be, you just got to plow through and just do 50 of these. Okay? You'll get tired of them, but then it'll be locked in your brain forever. And it'll come on back. Okay? So with that then, go ahead and find your worksheet on Google Classroom. Pull up. That would be the Monday classwork. And I had to change this a couple times because I thought the very same thing, like, we're just multiplying binomials? Okay, we need some practice. Here's a worksheet. And then I looked at it like, no, this is terrible. This is an awful, boring worksheet. So I went back and I found some fun worksheets. Okay? It's a little bit goofy, but that's what makes it interesting. You're trying to help Polly Penguin find her way back to her igloo. Down the bottom left corner. I don't know who designed this thing. I would have put the penguin here and the igloo down there. Whatever. We're starting at the bottom and working our way up. So, Polly the Penguin's start button. And I apologize that the way this captures the screen cuts off the end here. Let's see if I zoom in, can I move it up? There we go. All right. So we're starting with x plus 8 times x minus 5. Multiply those out. What do you get? Will it be x squared? Notation. I've got to turn my head. X squared plus 3x minus 40, or x squared minus 3x minus 40. This is where those mental math tricks can come in. With enough practice here, you should be able to identify which one it will be. You don't even have to do the whole thing. Right? That's the beauty of multiple choice, right? You don't actually have to work the problem out. You just have to eliminate the non-answers or identify the correct answer. There's only one difference between the two. Is it positive x positive 3x or negative 3x? So that's the thing you got to figure out. And then that'll take you on the path up to the next box or over to the next box, and then you multiply, you pick your path, and you work your way through the maze. Okay? Now, this is a PDF on your Chromebook. I understand that. The important thing is to work through the practice. Those of you here, or those of you at home with access to a printer, if you want to print this off, you may, that's fine. If you want to copy things down in your notebook and work out a path, at least identify which questions. So notice the question you get to in either box is going to be different. So we'll know your path taken by which questions you answer. Okay? Or if you want to, I sent this to the geometry kids because it was useful for their homework. I should probably post it for you guys too. There's a site that you can upload a PDF to and then draw on it online. So if you wanted to use that to actually draw your path in, actually run the maze yourself, if you would enjoy that, I'll go ahead and put that link in the resources. But otherwise, exactly how you present your final solution to me doesn't matter, as long as you have some method. Right? As long as you show your work and you've done the practice. Upload something to the picture of your notebook page, that's fine. Okay? So, that one's a maze. This one is 2 pages. It's kind of some goofy puzzles based on this is, let's see, if the you're trying to answer this baseball question. And if your final answer, you get solution ends in a negative number, you put a tally on Cincinnati. If it's a positive number, you put a tally on Dallas, and you see who wins. And then similar down here. Right? Here's all the questions, here's all the answers. Find the appropriate answers, and I think you shape those. They contain the solutions, and that'll spell out the answer to the riddle at the top. Yes, you probably know the answer without doing the math. That's okay. I thought these would be more engaging than just the plain old, here's problems 1 through 30, do them. Okay? You should be able to. I believe that's still the library printer. I've seen it working. Yes. Whole page, not Yep. There you go. Yeah, go ahead and pick those up. And I did just post the link to the website where you can upload a PDF and then draw on it online. So you'll probably have to download them from Google Classroom first and then re-upload. But if you want to do it entirely digitally, that's where you can do that. One final comment on homework before I close out the stream. Your homeworks are going to be, for this class, almost entirely on Khan Academy. Okay, so we'll just be using that as our homework exercise. Even though it calls them quizzes, I'm not grading them like quizzes. Right? But that's the segment of practice I can assign for you there at home. So similar to over the summer, the expectation is you'll achieve that mastery percent rank, and I will have a separate grade for that as well, for each topic on Khan Academy. And then to keep you paced, I'm going to assign a quiz like every day or every other day, depending on how many there are and how they space out throughout the week. Okay, so your homework last weekend was to finish quiz 1. And then tonight it'll be quiz 2, right? But you'll have, it's there on the schedule, right? I want you to finish quiz 2 by Wednesday. Right? So you don't have to do it tonight, you could do it tomorrow night. It's a week of homework that's assigned. It's up to you to then monitor your time and do the, manage that appropriately. And with that, then, we will end the YouTube stream. Thank you for watching.